Welcome to this video. I'll show you how to propagate uncertainty through exponentiation, which means raising a measurement to some power. Let's say you measure your height, and it's 24 plus or minus 3 centimeters, like that. And you want to take your height, for some reason, and raise it to the power of 2.5. You do that, you take 24 to the 2.5, and what do you get? 24 caret 2.5. It's 2, 8, 2, 2, roughly. And the units would actually be centimeters to the 2.5. But this value has uncertainty. After all, the height has uncertainty. How do you find the uncertainty in this new value? Here's what you do for any exponentiation. Here's the rule. If you take some value h and some measurement and you raise it to some power n, you find the percentage uncertainty in the new number by taking your power n, making sure it's positive, and multiplying by the percentage uncertainty in the measurement. Okay? Let's see this in action. So, for example, in this top example in blue, you would find the percentage uncertainty in this value, the percentage uncertainty in that value, which we'll call h to the 2.5, is going to be equal to 2.5. It's already positive, but we'll put the absolute value anyway, times the percentage uncertainty in height, which is 3 over 24 times 100%. That's our rule. Let's take a look at number 1. A sphere has a radius of this. There's the volume of a sphere equation. Find the percentage uncertainty in the volume. Here's what you do. The percentage uncertainty in the volume, well, let's see. To get the volume, you multiply these three things. Whenever you multiply three things together, the percentage uncertainty is found by adding the percentage uncertainty in 4/3 plus the percentage uncertainty in pi. You see, this sounds a little strange, doesn't it? Plus the percentage uncertainty in r to the third. But 4/3 is perfectly known. It doesn't have any uncertainty, so the percentage is 0%. And pi is known, so the percentage is 0. So all we have to worry about is finding the percentage uncertainty in r cubed. That's the thing that remained. That's the only thing which is not 0. So let's find the percentage uncertainty in r cubed. We're taking r, we're raising it to a power. You find the percentage uncertainty by multiplying the power, absolute valued, by the percentage uncertainty in r. So what's the percentage uncertainty in r? It's simply 0.8 over 14 times your 100%. That's a percent sign. So you plug this into the calculator, and you get 17.14. And that's gonna, when you report the answer, round it to 17%, like that. Okay, part B, that's all part A. Part B says find the absolute uncertainty in the volume. Well, the percentage uncertainty we know, and we know that the general equation for any percentage uncertainty is absolute uncertainty over the value times 100%. We know this already. It's 17.14. We're looking for that, the absolute uncertainty in volume. Volume we can find using the equation here, 4/3 pi r squared. So we know what r is, we find volume that way, we plug it in, and then we solve for delta V. Now, you want to show that step of calculating volume. I'll put it on the side. It's usually good to do it as a separate step. Volume is 4/3 pi times r cubed, which is 14 cubed. And you calculate this, it's going to be a really, really big value. Let's see, pi times r cubed, r is 14. This is going to be huge. 11,000, let's say roughly 11,494. The units are going to be meters cubed because you cube the meters as well. Okay, so now you come back to this work here. We know what this is, delta V. We know the percentage uncertainty in V. That is 17.14. We use the unrounded value from above. This is only rounding for reporting the answer. In subsequent calculations, we use the unrounded answer. And 17.14. We know what the volume is now. That can be replaced with 11,494 meters cubed. Right, like so. And then you solve for delta V. Delta V has units. You have to remember to round it to 1 sig fig. And you get, when rounding to 1 sig fig, you get 2,000 meters cubed. So the final thing you would do is write your final answer. Let me put that in blue. V equals the value plus or minus the uncertainty. We have one final thing to do. We have to round the measurement to match the precision of the uncertainty. The uncertainty is rounded to the thousands place, so we have to cut off this number, round it to the thousands place as well. It's going to be either 11,000 or 12,000. Well, we round down to 11,000 because this is not a 5. It's less than 5. So let me erase that and round down to 11,000. And that's our final answer. In the next one, they're looking at a cube which has a side equal to this amount. They don't give you a formula like they did above. They are requiring you to remember that a cube has a volume equal to its length, the length of the side. Let's call it S cubed. That's the formula for volume of a cube. So you do the same thing as above. The percent uncertainty in volume is going to simply be equal to the percent uncertainty in S cubed, which is, you take the power, absolute value it, and you multiply by the percent uncertainty in the measurement, S. S is our measurement, it has uncertainty. So that's how you do part A. Part B is the same thing as before. You're going to have to actually calculate the volume by doing the side cubed, get an answer, and then you'll use the general formula for percent uncertainty, which is this. At this stage, you'll know volume, you'll know the percentage uncertainty from above, and you can calculate this. The last one I want to show you is it has a power of 2.5. And this is not so bad. You do the same thing as before. The percent uncertainty in mass raised to the 2.5, whatever that value comes out to, it has uncertainty. And the uncertainty you get by taking the power, absolute valuing it, and you multiply by the percentage uncertainty in M, the measurement itself. So the percentage uncertainty is just 3 over 25, right? 3 over 25 times 100%. So that's part A. Part B is the absolute. You do the same thing as before. The absolute uncertainty in m to the 2.5 divided by the value itself of m to the 2.5. You can calculate what that is, times 100% gives you the percentage uncertainty in mass to the 2.5. You know what this is from above. Mass to the 2.5, you find that by taking 25, right? The mass is 25. Raise it to the 2.5 power and get your answer, and then plug in that answer right here. And then you'll know this as well, and you can solve for this, which is just one big variable. Isolate that big variable in the box, get it by itself, and then find out what your answer is.